Alright, good day once again class, and for this video we are going to solve a simple equilibrium problem, no? Sa ato ang discussed before. Alright, so allow me to read the problem. The cable and beam shown support a load of 500 newtons. Determine the tensile force T in the cable and compressive force C in the boom. So basically, what the problem wants us to solve is the compression force on the boom and the tensile force in the boom. All right. So let's solve this one in a conventional way. All right. So first things first, what is the first thing that we want to do? Again, the first step is mag-move on. Charot lang. All right. So again, first step is to draw a free body diagram. All right. So where do we want to center our free body diagram? Basically in the point where all the forces are acting. All right, so drawing that free body diagram here, so basically if we have that center point here, we have our 500 Newton force going down. It's 500 Newton force. And we want to represent also the compression force or compressive force, just like that. All right, sorry. Oops. Let's do it a little bit straighter. All right, so let's just say FC. Okay, so compression force going towards the point, and then we also have our tension force going away from the point, and we also have their angles. So basically, let's just draw a little separation line here. So we can say that this is 30 degrees and this is 45 degrees. All right, so FC, we label that one as FC, so we will label this one as our FT, or tension force in the cable. All right, so after we draw our free body diagram, what's the next step? So basically, we want to establish equations, right? So not a relationship, but equation. Charot lang. Okay. We want to establish an equation that has a relationship. All right. So again, proceeding to our second step. Proceeding to our second step. Okay. We want to satisfy how many equations for these particular problems? Basically, two. So again, in our static equilibrium equations, we have three to name. We have the summation of forces x, or summation of forces horizontal, should be equal to 0. We have the summation of forces y, should be equal to 0. And we also have the summation of moments, should be equal to 0. So if we satisfy this one, basically our problem is in static equilibrium. All right. So since we want our setup, since we want our setup or our problem to be in a static equilibrium, basically we want to satisfy or suffice these particular equations. All right. Therefore, all forces going to the right should be equal to all forces going to the left. Okay. More so, in our vertical components, all forces going up should also be equal to all forces going down. All right, so let's proceed. So what are the forces? If we sum up our forces, let's just say summing up forces x should be equal to 0. All right, so what are the forces horizontal forces here? So basically, we have the horizontal component of Ft. Okay, so Ftx. And we also have the horizontal component coming from Fcx. Okay. All right. So summing up forces, what are the forces going to the right? Basically, we have Fcx. So let's just write that one down. Fcx is equal to our forces going to the left, Ftx. All right. So basically, the horizontal component of Fc is just equal to Fc cosine, since we are using angles, cosine of 45 degrees. All right. And the horizontal component of our Ftx is just equal to Ft cosine of 30 degrees. All right. So with that, no, if we want to make it, or if we want to make it a much simpler equation, so let's just say we have FC cosine of 45 degrees minus FT cosine of 30 degrees. This should be equal to 0. So basically, we have our first equation. Okay, so I'll just go ahead and write that one on the other side. Equation 1. All right, so what's the next equation? We want to establish another equation. Okay, so we are going to sum up forces vertical. Okay, so if we sum up forces vertical, summing up forces vertical, that should also be 0. All right, so what are the vertical forces in this particular free body diagram? All right, so we have the vertical forces here as the vertical component of Ft or Fty, and we also have the vertical component of Fcy. All right, so we also have our downward load, no, which is in vertical 500 newtons. And again, remember that our vertical component should be equal to, no, the forces going up should always be equal to our forces going down. Now, what are the forces going up? So we have the Fty plus our Fcy. And what are the forces going down? We have 500 newtons. Okay, so simplifying further, right? So Ft sine of 30 degrees plus Fc sine of 45 degrees is just equal to our 500 Newton load. So basically, we have our second equation. All right. Okay. So what's the next step? Sir, what's the next step? Okay, so the next step is just to solve for or represent one force to the other. Okay, so since we already have two equations to unknowns, basically using our calculators, no, mode 5, we can automatically solve for two unknowns. But then again, no, since we want to solve this one conventionally, we want to represent one force. Oh, we want to represent Ft in terms of Fc, for example. All right. So by doing so, let's just say our Fc, okay, our Fc, sorry, our Fc is just equal to our Ft cosine of 30 degrees all over cosine of 45 degrees. So basically, we represent our Fc in terms of Ft. And then substitute. No? Substituting equation 1 to equation 2. No? Substituting equation 1 to equation 2. Basically, we will have our answer for Ft. Right? So writing down equation 2, we have Ft as our unknown, sine of 30 degrees plus Fc, and we already know the value of Fc in terms of Ft, so just substitute it there, no? Cosine of 30 degrees over cosine of 45 degrees. All right, and don't forget to multiply it with our sine 45, so that should be equal to 500 newtons. Therefore, solving for our Ft, no, Ft, we will be able to get 366.03 newtons. All right, and sir, how are we going to solve for Fc? No, by substituting Ft, the value of Ft, in here in our previous equation, derived equation. So basically, we will have the value of Fc as 366.03 newtons cosine of 30 degrees all over the cosine of 45 degrees. So basically, the value of Fc, let's just write it here, Fc is just equal to 448.29 newtons. So there you have it, class. So basically, our answers, no, for the compressive force and the tensile force in the cable and the compressive force in the boom should be, for the tension, we have 366.03 newtons, and for our compressive force in the boom, we have 448.29 newtons. So basically, these are our answers. All right. So I hope that you're able to learn something from me today, and that's it for our video.